G'day, I'm Rob Miller from the Bses in the Burdekin. I'm the Rwue Water Use Efficiency Initiative Extension Officer for the region. Sugarcane is the major crop grown in the Burdekin region of North Queensland, covering an area of around 83,000 hectares. Almost all this land is furrow irrigated from the underground aquifer, as well as water sourced from the Burdekin Falls Dam. This dam stores over 1.86 million megalitres of water, which is released into the Burdekin River throughout the year as growers require it. The water is then relifted into a network of distribution channels and conveyed to the farm gate. Around half of the irrigators also use groundwater from the aquifer underneath the Burdekin Delta. Irrigation water is distributed on farms generally by underground pipes and lay-flat fluming. Water is released into the furrows through plastic cups. Furrow irrigation is easy to operate and has a low operating cost because the water does not need to be pressurised or filtered. The main disadvantage of furrow irrigation is that if it's not managed properly, inefficient water use can result. The objectives of the Rwue Water Use Efficiency Initiative were to increase average water use efficiency by 6%, involve 70% of irrigators in adopting irrigation best management practices, improve productivity by half a tonne of cane per megalitre, reduce offsite impacts associated with irrigation. At the time of recording, the Burdekin region is well on the way to achieving most of these goals by June 2003. A simple and effective way of knowing when to irrigate to meet crop requirements is by using an evaporation pan. The evaporation of water from the pan can be related to crop water use demand. A simplified evaporation pan is the Bses micropan. To use the micropan, simply fill it up as soon as an irrigation is completed. The water in the micropan will level with the V cut into the side. After a number of days, the water level in the micropan will drop. Once a preset level has been reached, it is again time to irrigate and repeat the cycle. In order to determine this level, we need to calibrate the micropan evaporation to crop growth rates. Before use and calibration of the micropan, the average daily temperature needs to be above 24 degrees centigrade. Most often this occurs from around October through until March. This is the optimum growing time for cane, so therefore is the time when water should be applied as efficiently as possible. Also, ensure that the height of the top visible dewlap is at least 1 metre from ground level. Calibration of the micropan is very important as growth rates can vary between varieties, soil types and even blocks within a farm. It is advisable to carry out a number of calibrations if there are variations in soil type or cane varieties across a farm. If only one calibration is going to be carried out, choose a representative soil type, crop and general growing conditions. For example, do not choose a very poor section within a block or an area where the soil type is quite different to the rest of the farm. Once a representative furrow has been selected, mark the start of the furrow so it can easily be recognised. In order to carry out a calibration, 25 representative sticks of cane need to be selected. Walk down the furrow at least 5 to 10 metres. This ensures that any extra compaction, waterlogging or hill variations at the start of a row are not affecting the readings, as well as edge effects such as increased exposure to wind and sunlight. Selecting a stick every metre or so is generally sufficient. Ensure that healthier rather than poorer sticks of cane are selected. As each stick is selected, tie a piece of marking tape around the stick so it can easily be recognised. At the base of the stick, place the supplied cap or milk bottle top into the soil surface firmly, within a few inches of the stick. This allows a reference point to measure from each day when determining the growth. It's best to set the calibration side up the day before an irrigation, as this means that the ground won't be wet and it makes life much easier. While you are marking the stalks of cane, also measure the height of each stick and record this information. Then, every day afterwards, record the height at the same time each day. Generally between 6 o'clock and 9 o'clock in the morning seems to be a convenient time for most people. In order to measure the height of cane, we measure from the cap on the ground to the top visible dewlap or growing point. This can be seen here and is marked with the darker ring around the cane stalk. This particular height is 1630 millimetres. As the plant grows, this top visible growth point will change as more leaves unfurl. When you measure each day, ensure you measure to the top visible dewlap, which will change over an irrigation cycle. Record each measurement on the sheet provided in the measured height column, corresponding to each stalk, numbered 1 to 25. Ensure that the date for each column is recorded at the top of the sheet, as well as the weather conditions down the bottom. Simply tick the box that is appropriate. For example, if it is quite a cloudy day, tick the 75% cloud box, or if there is no cloud, tick the sun box. Also, tick the irrigation box on the day when the crop is irrigated, and record any rainfall that has fallen over the calibration period. For the calibration to work most effectively, there should be full sun all the time. Cloud cover can restrict crop growth and give misleading results. For this reason, it may be necessary to carry out the calibration over a number of irrigation cycles if there are less than ideal conditions, to get a better feel for crop growth rates. If a rainfall event or excessive cloud cover occurs, stop the growth measurements until the weather has passed and start the next irrigation cycle. Once we have measured the cane height each day over a normal irrigation cycle, we can carry out a few simple calculations. At the bottom of each column, in the total row, we add all the stalk heights from 1 to 25 for each day. To get the average length figure, we divide the total by 25. After this has been calculated, we can see how much the plant has grown each day. What we notice in most cases is that the crop responds by growing more initially, and then the growth rate drops off after a few days. Typically, a growth curve looks similar to what you can see here. Remember that different varieties and soil types affect the shape of the growth curve. Generally though, there is that period of increasing growth until it reaches a maximum, and then it will start to decline, in some cases more rapidly than others. In order to make the greatest economic return from cane, we need to keep the growth rates as high as possible, as long as our water allocation allows this. As a rough guide, every millimetre that the cane grows is approximately worth 80 cents each hectare. This means that once growth rates slow down, this is money that cannot be recovered. As a good starting point to determine when best to irrigate, we suggest determining what half our maximum growth rate is, and then this can be selected as the time to irrigate again. This half point has been selected for ease of management with a furrow irrigation system. If other systems, such as overhead or drip irrigation, were being used, we would choose a point much closer to the maximum growth rate as our re-irrigation point. Again, this is easy to see if we plot the growth for each day on a chart. Here we can easily see that the maximum growth occurs on day 2 to 3 at 22 millimetres, so half of 22 is 11. This means that once the daily growth drops to 11 millimetres, it is time to irrigate again. This particular example shows that this happens on day 5 after an irrigation. In order to combine the growth measurement information with the micropan, we also need to measure the decrease in water level in the pan each day. This is placed on the sheet in the micropan row. Read the level of water after taking the stalk height readings, writing the figure displayed on the ruler on the inside of the pan. After we have determined when the optimum time to irrigate is, we mark this number on the outside of the pan, or remember the number on the ruler. For example, if half the daily maximum growth rate occurs when the pan level is at 90 millimetres, every time the pan reaches this level in subsequent irrigations, this is the required refill point. Ensure that the micropan is placed in an area that is representative of the wind and sunlight conditions experienced by the crop. Place the pan in an open area where it will not be protected from prevailing winds or shaded by any objects such as sheds, trees or machinery. Remembering that if it is to be placed near the cane, that the cane will grow and could potentially block wind effects. It is also advisable to put the pan up out of reach of dogs or wallabies, possibly on a 200 litre drum or some bricks. If birds drink from the pan, it may be advisable to put a mesh cover over the top. Make sure that this cover is in place when carrying out the calibration, as it can have a noticeable effect on evaporation rates. Another way of scheduling an irrigation is by using a tensiometer. A tensiometer is a hollow plastic tube with a sealed lid and a porous ceramic tip. The tube is filled with water and pushed into the soil. The vacuum pressure is measured each day, and this reading is representative of the suction required by plant roots to extract moisture from the soil. As the tip of the tensiometer is quite small, the suction reading is indicative of the area immediately around the tip of the tube. This means that if the tensiometer is placed in the interspace, it will only measure soil moisture changes in that area. In order to properly monitor the plant moisture requirements, we should be placing the tensiometer in an area heavily populated with plant roots, not one where there are gaps in the crop. Unfortunately, plant rooting patterns differ from block to block. This means we need to dig up a section of the row and determine for ourselves where the roots are for a particular block, which will change with varying soil types, varieties and farming practices. When digging for roots, dig a trench beside a plant and dig from one interspace to the other. Scrape away excess dirt from the sides with a screwdriver in order to expose the roots. Most of the roots are in this area here, so the best position for the tensiometer would be right in the middle of the root cluster, around 250 mm deep. In other cases, roots can be deeper, shallower, and often quite spread out laterally. In some sodic clay soils, roots have been seen to be only a few centimetres deep and spread right out to the centre of the interspace. It is easiest to push the tensiometers into the soil after an irrigation. The moist soil also ensures a good seal around the ceramic tip. Ensure that the tube is almost filled with water before installing it. Periodically check the water level in the tube, as it will need to be refilled occasionally, particularly if suction levels are high. The rubber bung on top may also need to be replaced after a number of readings have been taken, or if they have been exposed to sunlight for a period of time. In order to read the tensiometer, we simply take the reading unit, turn it on and insert the needle through the rubber bung, and the display tells us the suction pressure of the soil. As a very rough guide, cane grows at its best between readings of 15 and 40. Once again, like the micropan, tensiometers give the best indication by calibrating them to cane growth measurements. On the same calibration sheet used for the micropan, there are spaces for tensiometer readings so they can be recorded each day. Tensiometers are a much more versatile tool than the minipan, as they can be used all year round, not just in the peak growing period. Tensiometers, once they've been calibrated, are not affected by cloud cover or rainfall events, and therefore become a much more useful tool in these circumstances. In the past, some growers have become a little confused as when to re-irrigate after a rainfall event. Tensiometers tell us exactly how hard the plant roots are working to extract moisture from the soil, so we know when the plants require irrigation. Install tensiometers when soil is moist. Place the tensiometer where the majority of roots are. Check the level of the water in the tube periodically. For any further information on any of the topics covered in this production, please feel free to contact the relevant BSES Extension Officer in your area.